Okay, guys, welcome back to my YouTube channel. Now, today we'll be discussing or solving questions on relative density. I hope you've watched the previous videos. If you've not, please kindly go back to watch the previous videos. Today, we'll be solving questions on relative density. Now, the question shown on the screen says the mass of a specific gravity bottle is 15.2 kilograms when it is empty. It is 24.8 grams when filled with kerosene and 27.2 grams when filled with distilled water. Calculate the relative density of kerosene. We're going to make a correction in that question. It is not 15.2 kilogram, it is 15.2 grams. Now, how do we solve that question? Come back to the board. Now, I've brought out the parameters that the question gave to us. We have the mass of the empty density bottle, 15.2 grams. We also have the mass of the bottle when filled with kerosene as 24.8 grams, and the mass of the bottle when filled with just distilled water as 27.2 grams. I'm sure you're going to know, we're going to apply the formula for the liquid because kerosene is a liquid. The formula says mass of liquid divided by mass of equal volume of water. Now, how do we get the mass of the liquid itself? In this case, kerosene. You agree with me? To get kerosene, I'm going to do M2 take away M1. So we're going to do in M2 minus M1. That will give us the mass of kerosene. You agree with that? And then to get mass of equal volume of water, we're going to do M3 take away M1. That will give you the mass of equal what now? Volume of water. Now, what is 24.8 minus 15.2? Let's check that on our calculator. Okay. 24.8 minus 15.2. That gives us 9.6. Okay, so 24.8 minus 15.2 gives us 9.6. 9.6. Okay, we have that. And then at the bottom, we're going to be doing 27.2 minus 15.2 again. 27.2 minus 15.2 gives us 12. So we have 9.6 divided by 12. Now just divide those two values with your calculator and the answer for the ROD for kerosene becomes 0.8. Okay, we have a question displayed on the screen. It says, a solid of weight 0.6 Newton is totally immersed in oil and water respectively. If the upthrust in oil is 0.21 Newton and the relative density of oil is 0.875, find the upthrust in water. Remember, we said we could relate relative density to upthrust, which we said relative density of that liquid becomes upthrust in liquid divided by upthrust in water. Upthrust in liquid divided by upthrust in water. Hence, ROD in this question is 0.875. Therefore, 0.875 becomes equal to the upthrust in the liquid is 0.21, and we are looking for the upthrust in water. Therefore, if you cross multiply and make this guy stand alone, you have upthrust in water to be equal to 0.21 divided by 0.875. Let's check that in our calculator. 0.21 divided by 0.875, and that gives you 0.24. 0.24 Newton, and that is the answer. Okay, we have a question displayed on the screen. It says, a body of density 0.8 kilograms per meter cube weighs 120 newton in air. It is suspended with a string with half of its volume immersed in a liquid of density 0.6 kilograms per meter cube. Find the tension in the string. Now, I have written out the parameters. The density of the object 0.8 kilograms per meter cube. The weight of the object 120. Let's quickly bring out the mass of the object. The mass of the object will be the weight of the object divided by g, because we all know weight equals mg. Therefore, m equals weight divided by g. And that will give you 120 divided by 10, and that should be 12 kilograms. So we know that the mass of the object is 12 kilograms. Why did we bring out the mass? Because we need to know the volume of the object. Recall, VO is the volume of the object immersed in the liquid. V is the actual volume of the object. Now, the question said it only had half of its volume immersed. So the VO is half of the V. Now, therefore, we need to find the volume. Recall, density equals mass divided by volume. Therefore, volume should be mass divided by density. Now, the density we're going to be using is the density of the object, not the one for the liquid. Therefore, the mass is 12 kilograms divided by 0.8. Let's check that out. 12 divided by 0.8, that gives us 15. So the volume of the object is 15 meters cube. Therefore, the volume in mass becomes half of this value. So the volume becomes half of 15, and that should give us 7.5 meters cube. We now know the volume immersed. Therefore, how do we find tension? Recall, tension equals weight minus upthrust. We already know the weight. Now let's solve for the upthrust. Upthrust equals density of liquid, volume of objects immersed, and acceleration due to gravity. Let's plug in the values we have. Density of liquid 0.6. Volume of objects immersed 7.5. Gravity 10. Therefore, if you multiply these values together, you're going to have times 10, we have 45 Newton. The upthrust is 45 Newton. Now, the tension becomes the weight. The weight is 120 Newton minus 45 Newton. 120 Newton minus 45 gives us 75 Newton. So the tension in the string is 75 Newton. Okay, we have a question being displayed on the screen, and it says a body of mass 36 kilograms falls through a viscous liquid which offers a drag force of 260 Newton on the body. The upthrust on the body at terminal velocity is dash. Now, take note, they said terminal velocity. Remember, we said at terminal velocities, your acceleration must be equal to 0. Recall, weight minus upthrust minus viscous equals to NA when you are falling through a liquid. But because it is terminal velocity, A becomes 0. Therefore, MA becomes 0. We are asked to find the upthrust. If you take upthrust to the other side of the equation, we are going to see that upthrust should be equal to weight minus the viscous force. In the question, we were given the viscous force as the drag force. And what's the value? 260 Newton. Now, do we have the weight of the object? No. But do we have the mass? Yes. The mass is 36 kilograms. Recall, weight is equal to mass times acceleration due to gravity. So we can quickly say 36 times the g is 10. This gives us 360 Newton. Hence, upthrust becomes 360 Newton minus viscous, which is 260 Newton. And therefore, the answer becomes 100 Newton.